Assalamualaikum, so I'm Alia. So I'm doing the question 1A, which is the question asks to construct the house range Fourier cosine series over L prime A naught T dt. X over Y over 2, the value for A naught, we need to find the values of A n, which is A over L dt. This is exponent and cos. With non-zero terms, approximate the temperature distribution. The question B.
Hi and Assalamualaikum. For question C, the cosine series is solved for insulate boundary condition heat transfer problem because heat flux directly proportional to the temperature gradient. And when the fluid tank is insulated, the temperature slope means temperature gradient must be zero at the boundary. Means that dt per dx equal to 0 at x equal to 0 and x equal to L. Therefore, differentiating cos n I t over L modules per sine term, since sine 0 equal to 0 and sine n pi equals to 0. The temperature gradient vanish at the boundaries. Lesson 23. The boundary boundary condition del t per del x equal to 0 is automatically satisfied.
Question D. Construct the half-range Fourier sine series. Sine n pi t integrate 0 to L on dt.
For question E, is the sine series more appropriate in mechanical system? The sine series is more appropriate when a system has fixed boundary condition, where the function value drops to 0 at the boundaries, which is x equal to 0 and x equal to L. The key reason is 0 value mathematically sine 0 equals to 0 and sine n pi equals to 0, and this naturally satisfies the Richard boundary condition. For calculation, it simplifies the final equation as terms at the boundaries will result in 0. For example, a string fixed at both ends, and second, a rope with fixed ends held at a constant 0 temperature, which t equals to 0 at x equals to 0 and x equals to L.
My name is Adriana Patricia from BELG Section 1. So today I'll be explaining about assignment question 1.
Less than x less than 30 cm, which means at point E the x is 0 because it is equilibrium, so it was at rest, and at point B x equals to 30 after being put, and these both are ends and cannot be moved. So we're going to use a wave equation, which is utt equals to 9uxx. Alright, so at end A u0t equals 0. At point B u30t equals 0, and t must be more than 0. So the question said a point located 10 cm from end A is pulled to the string and released. So at t equals 0, the string forms the triangle shape. This one. Yeah. So using the coordinate, which means coordinate A is 0, 0. Pull point is at 10, 3, which means here. Pull point is 10, 3. And then at point B is 30, 0. Okay. So from 0 less than x less than 10, we're going to use y equals to mx plus c to find the equation. So we need to find the m first, which is m equals 3 minus 0 over 10 minus 0 using this coordinate, pull point and a point. So m equals to 3 over 10. So the equation must be ux0 equals to 3 over 10x. Okay, so for 10 less than x less than 30, we're going to find the m first. 0 minus 3, 30 minus 10 using pull point and b point equals to negative 3 over 20. Okay, so the equation is y3 equals to negative 3 over 20 x minus 10. So how do I get the equation? The equation is from y equals to y1, y minus y1 equals m x minus x1. Okay, so we will get x0 equals 9 over 2 minus 3 over 20x. 0 equals 3 over 10x and 9 over 2 minus 3 over 20x. Like we get, and then just insert it. 0 less than x less than 10, 10 less than x less than 30. So we need to find the initial velocity. Since the question state that it releases from stress at equals 0, so of course u d x0 equals to 0.
Assalamualaikum, my name is Anna Sofia binti Ahmad and I will be presenting question 2b. As we given the equation x dt x d double prime equals 9 x double prime t. As given the variables, we already get x prime over x equals to t prime over 90 equals to t. This is to two ordinary differential equations. 1 x prime minus p x equals 0 and 2 p prime minus 9 pt equals 0. T equals 0 into equation 1 just now. So x prime equals 0 into x prime got x double prime got x prime equals a and we have x equals to ax plus b. This is the second question of the equation. So now we have a condition to solve for the also we have x0 equals 0. So x0 equals to a0 plus b. The x0 is 0, so we have p equals to 0. And the second one we have x t equals to 0 and we have equals to x t plus b equals to 0. Since we know b equals 0, this becomes t a and equals 0, a equals 0. Since both of them are 0, the function becomes x equals to 0 times x plus 0, so we have becomes x equals to 0. This implies that u x t equals to x t multiplied t equals to 0. This gives the first solution, hence we only use case computed. Now we have case 2, which is p greater than 1, let p equals to lambda squared, and lambda is greater than 0. Substitute p into equation 1, which is x prime double prime minus lambda squared times prime equals to 0. This is the second ordinary homogeneous. It has a characteristic equation which is m squared minus lambda squared equals to 0. We get m equals to plus minus lambda. So since the root are distinct, the general solution should be x equals to ax to the power lambda x plus b to the power lambda x negative lambda x. With this we can apply one equation which is x0 equals to 0. Yeah, so we get x0 equals to ax log lambda 0. This is x b 0 plus b minus lambda 0. So now we got a1 is to the power 0 1, and then plus b to the power of negative 0. We got also 1. So we have equation a plus b equals to 0. But if this one expression which is we use b equals to negative a. And then we apply the second equation which is x equals to 0. X t equals to a to the power of lambda plus b to the power of lambda negative lambda equals to 0. So now we can substitute the equations now into the equation. We get a to the lambda minus we substitute b. We got a to the power negative lambda equals to 0. Now we factorize the equation. We got a negative to the lambda minus c negative to the lambda equals to 0. We also get plus we will be doing the equation. So let's have case 3 which is p less than 0. We get p equals to lambda squared and we greater than 0. So we substitute the p which equation 1 which is x prime plus lambda squared x equals to 0. And it will be m squared plus lambda squared equals to 0. And since these are imaginary roots, we will get m equals to plus minus lambda 5. So now we will get x0 equals tan 0 plus b sin 0 equals to 0. We will get a equals to 0. And for the second one we will get x equals to b sin 50 lambda equals to 0. So now that b is not equals to 0, we set sin 50 lambda equals to 0. We find that 50 lambda equals to n by n multiply. And the n value is 1, 2, 3, and so on. And we got by lambda n equals to we got x sin x equals to then we substitute the lambda n into the equation 2, which is t squared plus 9 multiple n pi over 30 n squared and then t equals to 30. So we substitute we got t double prime plus 3n pi over 30 squared t equals 0. And we got the general solution will be t n t equals cn cos over n pi t over n plus t n sin over n pi t over n. My other solution by applying the position principle u x t equals and the next thing we apply the integral function to find coefficient using ut x t equals to. And then we solve this, we will get we have n equals 0, apply initial differential function, which is u x 0 equals f x, and we apply this. Using the position equation by the double equation, en equals 2 over t, integration at t 0 fx sin multiple n pi x over t dx, and solve it using the derivative. You will evaluate using the derivative or any other alternative by integral using multiplication by parts and so on. And you substitute in and find the position equation, which is u x t equals to. We have it. There's
For question C,
the question gives 15 x equals to 15, cm and t equals to 5 seconds. Using the formula from part B, the solution from part B, which is u x t summation of pi squared n squared sin n pi over 3 cos n pi t over 10 sin n pi x over 30 u 15, which is x and t is 5. Okay, so please substitute 81 pi squared n squared sin n pi over 3 sin n pi 20 because t is 5 and over 10, which means sorry, this is 2. Okay, so cos n pi over 2, which means sin n pi 3, n equals to 1, n equals to 2, and n equals to 4. For n equals to 1, sin pi 3 equals sec 3 over 2. So you get cos pi over 2 equals 0, and t1 equals 0. So for n2, insert back, sin n pi 3 equals to sec 3 over 2, sin pi equals 0, t2 equals 0. So for n4, sin 4 pi over 3 equals to negative 3 sec 3 over 2. So you get sin n 2 pi equals 0. So t4, so u15 5 equals to t1 plus t2 plus t4, which means 0 plus 0 plus 0. So u15 5 equals to 0, add x equals 15 sin n pi over 2, which is 0 and even, plus minus 1, and it's odd. Add t equals 5 cos n pi over 2 equals plus minus 1 and it's even, 0 and it's odd. So if n is even, sin n pi over 2 is 0. If n is odd, cos n pi 2 equals 0. Therefore, every term is 0. So which means u15 5 equals 0 cm. So the midpoint
is at its equilibrium position at t equals to 5 seconds. So that's